I'm Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT. And this is a Gestalt IT roundtable focused on the topic of big memory and the future of computing. We recently saw Intel introduce this second generation of their 3D XPoint products. And then just a few months later, we heard that Micron is no longer going to participate in the development of this advanced technology. We've also seen companies rising to introduce big memory products, especially the company that we have joining us today, MemVerge. Let's get into that discussion, but before we do, let's meet our panelists. Charles?
Hi, my name is Charles Pham, and I'm co-founder and CEO of MemVerge. Look forward to discuss with you anything about big memory.
Hello, my name is Frederic Van Haren. I'm the founder of Highfence, which is a consulting and services company active in the HPC and AI markets.
And I'm Justin Warren. I'm founder and chief analyst at Pivot9 Consulting.
Well, thank you very much for joining us today. One of the biggest topics in enterprise technology right now is the future of the data center, and specifically the role of memory and storage and networking and the changing architectures of all of these components within the data center. We recently heard more about MemVerge at our Tech Field Day events, and we were pretty excited by what they were suggesting could be built with technologies like persistent memory, such as Intel's Optane 3D XPoint products. But then we heard that Micron was going to be getting out of this market, and there was a lot of people saying, well, maybe that means that this stuff doesn't have a future. Personally, I don't agree with this. I feel like there's a huge future in persistent memory generally, and in software that enables persistent memory in computing and changes the architecture of the entire computing stack. Charles, that's pretty much what you're building at MemVerge, right? Something that makes us, allows us to use this new technology in novel and exciting ways.
That's right. I think there is no debate, from Intel or Micron or us, that the world is going more memory centric. I think the only debate perhaps is more on the technology side. What's the right media and what's the right interconnect and what is the right architecture to achieve it? So first of all, let's look at the application demand. The world is seeing more and more data and more applications that need to process data in real time. And only memory has the speed and capacity to address this need. And that's a fundamental reason for the world going towards a big memory architecture or memory-centric architecture. And there's also no doubt that there is work both on the new media types as well as a work on the new interconnect. I think what Intel pioneered 2 years ago with Optane persistent memory is first of these new kinds of media that can give you higher capacity, lower cost, and performance at near the DRAM speed. And it is also persistent. And then on the interconnect side, there are technology like CXL that are also important that allow the interoperability between various processing units and various memory media to be all connected both within the server and between servers that are close to each other. I think these are two very complementary technology stacks that can come together to build a big memory architecture. And I think the announcement we see from Micron is really their focus of their contribution become less on the media front, but more so on the interconnect front. And these two are very complementary and not in competition with each other. And I think we'll continue to see innovations on the media front by companies like Intel and others in the future. And we'll see the realization of CXL and other interconnect, and that can work with this different media to enable a big memory world. And what MemVerge does is to sit on top of these infrastructure components and deliver these as software-defined memory services to the applications, and that's easier for these applications to adopt.
Yeah, I totally agree. I mean, I feel like Micron made a business decision, not necessarily a technical decision. Me coming from the HPC and the AI markets, there is a need for more memory-driven approaches. I mean, storage has always been a bottleneck, and although the technology has been improving, it is still significantly slower than memory approach. So I do believe that that 3D Crosspoint and Optane are good solutions today, and actually opens the door for new applications, right? There's a lot of the applications today are built with the assumption that there is not a lot of memory available, and that in the near future there will not be a lot more memory available to them. And I think that's what 3D Crosspoint and Optane is bringing to the table. It's improving the applications we have today with flexibility, and two, it opens the door for newer applications where larger memory sets can be used.
Yeah, and that's an advantage for MemVerge, I think, because MemVerge is software. So it largely doesn't matter what these other companies do. Someone is going to be creating persistent memory. It's Intel today. Maybe we're already seeing some other people with different approaches to how they're going to do persistent memory. They will need to interconnect in some way. The idea of having a large shared memory pool in the same way that we did with storage and having network attached storage and SANs. It's a similar idea, but the storage medium is memory. And that's something which I think we've all kind of gotten used to and forgotten, because we haven't done persistent memory since core memory. The reason we have hard drives is because we can't have persistent memory. That's what we wanted all along. So the fact that we can start having a bit more of that kind of takes us back as well as into the future.
Yeah, that's one of those things, Justin, that really always got me. I mean, the fact that there is this divergence between what's, okay, this is memory and this is storage, and they are different things and you need different everything. That's an accident of history and an accident of technology as much as it is a choice that was made. And Charles, I know you've been involved in this for a really long time as well.
Right.
You didn't see it that way.
Right. And I think it's not only an accident, it's now becoming the biggest bottleneck for data-centric applications. The fact that data has to be placed in memory and storage and has to be moved back and forth. I think one of the fundamental bottlenecks is a von Neumann bottleneck between CPU and memory. Now this I/O bottleneck is becoming equally difficult bottleneck for the applications, will be increasingly so. So our proposal is really to have a single memory tier where you put all of your data, and we do the software magic on top of it so that all your data infrastructure need can be met. It can deliver the capacity that you need, it can deliver the availability you need, and it can deliver certain user experiences that's not possible before. So while this is a fundamental change, I think, to computing architecture in the next 10 years, we are also already finding interesting use cases today that people can start taking advantage of the big memory architecture.
Right, and I do think, I mean, we can talk about performance and lower latencies, but if you have servers with more memory, there is a return on investment, right? You're going to have to buy less servers because you can do more with a single server. So I think that's one item we should also not oversee, is that performance and latency is great, but the return on investment is quite key. Is that it's important to keep on investing in innovation to move things forward. I think one of the big issues I see when people develop applications is that they still develop the applications the same way they have been developing applications the last couple of years, right? There's new technology out there like Kubernetes and other container technology that makes it a lot more challenging and could take advantage of that. And hardware, although it's becoming a commodity, it's still an investment.
Yeah, there's an accumulation of software as well. So we still have programs that were written in COBOL or are written in COBOL. I have a saying that the first 80% of writing software is putting bugs in, and the second 80% is taking them out again. So once you've made that investment in debugging things, rewriting it in a brand new way is actually pretty expensive. And that is unfortunately one of the challenges of things like persistent memory, is because it operates so very, very differently to the way that people are used to writing software. You have to rethink things. And so new programs with new use cases, it's much, much easier to write it in a new way. Whereas rewriting an older application to make it use a new method is a pretty substantial investment and a lot of change, and there's risk involved in that because you'll introduce bugs. So the fact that MemVerge provides that sort of shim layer, I find really interesting. And it's related to the consolidation point that you made, Frederic, because that's pretty much what VMware did early on. The original pitch was server consolidation, but it was a software layer that made virtual machines look like physical machines. And a lot of it early on was just that consolidation piece of lift and shift what you've already got, but use this new kind of technology. And I can see that happening a lot for a lot of software with something like MemVerge, where you can just put the memory machine shim in, start using persistent memory with the program you've already got while you kind of get used to it and it gets out there into the market a bit more. And then people who've been doing the new thing, that'll start to filter through to what everybody else is doing. I can see that playing out the way this would work. I hope so anyway.
Yeah, I do think it is a challenge for people. I mean, to your point, I mean, people don't like to change code because the amount of R&D time that went into building an application is very costly. But at the same time, it is challenging for these people to think differently and to innovate. Right? There's a high barrier of entry in order to go to new technologies, right? People understand memory, people understand storage, they understand faster storage, they understand faster memory. You know, persistent memory is a kind of a whole new topic that they have to wrap their head around, right? And that is also important, that there are a lot of reference systems and use cases, you know, and companies like MemVerge that provides that flexibility into their product, such that people can get going easily, you know, by just not changing the applications at all, and then they can go to an advanced mode when they want to use more of the advanced features that come with PMEM.
Yeah, I think that's well said, Frederic. And that's exactly the challenge we faced when we started the company 4 years ago, is that while persistent memory is great, but people are used to memory, people are used to storage, people are not ready to embrace, you know, most of them not ready to embrace a very new paradigm yet. So the approach we took is a virtualization approach, like Justin referred to. It's very analogous to what VMware did. And so what we presented is really a compatible memory API. So the application uses it just like you use memory. And how we take advantage of persistence is not necessarily through a new API, but through a mechanism called snapshot. So that is taking advantage of the persistence feature of the memory so that we can capture the application running state instantly and persist them on persistent memory. And through this mechanism, and this is something you can launch in a command line or in a UI, you do not have to change your program to do so. So this can be done, you know, without changing the programming model, and yet you can take advantage of the persistence in a natural way. For the more advanced users who are ready to change their program, of course they can do so, and we provide programming APIs to do this as well, but we can certainly accommodate those who are not ready to do so.
Yeah, that's, you know, kind of building on what Justin said and what you just mentioned. It really does seem analogous to VMware, where the initial pitch was, as Justin said, server consolidation, you know, take advantage of resources that you have. But the ultimate pitch was not that at all. The ultimate pitch was do more, do, you know, add features, add capabilities to the platform that you never had before. And, you know, for VMware, one of the big ones was disaster recovery and snapshots. And essentially, I don't want to say stealing their playbook, but essentially you're kind of ripping a page out of their playbook by doing exactly that, except for this this big memory. Is that right?
That's right. We are inspired by their playbook, and I think you hit the nail on the head. There are essentially two pitches we have. The first pitch is the consolidation pitch. If the size of the memory is your bottleneck, we can allow more VMs, more applications to run on a single server. Therefore, you need less servers to do the same thing. That means less hardware costs, less OpEx, less power, less everything. And so that's the first pitch. And that's also sort of VMware's first pitch. Now, the second pitch is beyond that. It's the productivity gain, the availability gain that you can achieve on top of this. And I believe this is even a bigger value proposition than the first one, than just the consolidation one. Essentially delivers a brand new user experiences. And I have a couple of very good examples that we're working recently. One is with genomics, and then we can have those biologists, data scientists doing work very different from the way they do before. Rather than a single data pipelining, now they can rewind, they can branch out, do what-if analysis very easily at the snap of finger. And before, to do that, they have spent hours to save the data, load the data. It's very complicated. And now it became a very intuitive, interactive process that we can let them to spend all their time on the real scientific geniuses that they can apply to COVID research, to cancer research. We have another example with the movie makers, the 3D animation studios, how they can run on top of our memory machine and editing their movies in very different ways and be more tolerant to failures as well. So this is the second pitch, is really delivering the new memory-centric user experience to the actual users who sit in front of that computer.
It seems like it's a perfect match to what's happening in the software application development world, which is Kubernetes, where there's a lot of focus on portability and stateless containers. Can you talk a little bit about that and explain how MemVerge will work nicely with Kubernetes?
Certainly so. So with this memory snapshot capability, we can essentially capture the running state of the application in a persistent way. And this has a potential to solve one of the problems with a cloud native setup with Kubernetes and with containers. So what do I mean by that problem? Kubernetes containers are great. It really changes the way we manage and deploy applications in a multi-cloud environment. But it's not as great with stateful applications. It's awesome with stateless applications. You can move them around, you can destroy them, stand them up very easily. But once it has state, once storage is involved, it becomes more difficult. There are more things you need to worry about, you need to capture, and it's not so easily portable from a cloud to a different cloud or from your on-prem data center to the cloud. Memory snapshot can be a powerful mechanism to create something we call memory capsule. And this essentially, working together with containers, can create a stateful instance of an application that's in a single encapsulation that allows you to move this application from server to server, from cloud to cloud, from on-prem to cloud. And you can restart that application, respawn that application statefully from the time when the snapshot is taken. So this provides an interesting new paradigm of enabling application mobility in a multi-cloud, cloud-native world.
One thing that I struggle with that concept, though, Charles, is that some parts of this do feel like we're porting across bad behavior into the future. We had similar concerns about VMware, where people would just, we'll just virtualize NT351 and then it's problem solved. So there is a bit of this idea, like containers are designed for stateless applications, and there are lots of reasons for why that makes sense. Whereas stateful data is a very different thing, and it's essentially a database. We used to do this. We had 3-tier architectures, and data was stored in a database, and application tier wasn't really stateful. It was just the code. Are we kind of repeating what we did with VMware and just taking old practices and picking it up and putting it on new, faster hardware and then not really fixing anything?
Yeah, it is a fine balance between accommodating the status quo and moving towards the future. So I think not by accident, I worked at VMware for 8 years. And during those 8 years, I think we were trying to find that balance where it doesn't require you to rip out all your existing infrastructure, and yet it gives you a pathway towards the future. And I believe our approach at MemVerge is similar, that at the same time, we do not require that you to completely change the way you do things as before taking advantage of the new technology. So that's where this shim, this virtualization layer, coming to play. But at the same time, we are introducing the SDK, which basically championing this new concept of big memory programming. Now, imagine if you have 100 terabytes available on a server to you. Are you gonna still use storage for your application design as an app developer? The answer is no. You would design architecture application very differently. And so through our SDK, you can do so very easily without, just completely changing your reasoning or logic, but just take advantage of this new memory through a new API. So in this case, you do not need to have to do the read and write. You're instead doing snaps of the memory region that you need to persist. So that allows you to lay out the data structure as you need it in memory and selectively to persist them through a snap mechanism. And so for the application developers who are willing to venture into this new ways of designing application, we provide SDK to allow you to do so. But at the same time, if you're not ready to do so, your old program will still work. Now the new program might work even a little better. So we basically provide a way to allow your existing workload to work, and yet you have a way to do things even more than that.
Which sounds a lot like the way cloud kind of happened, although not on purpose, because cloud started off as, no, you have to do things in a completely new, very, very different way,
right,
which worked fine for people who were doing brand new stuff.
right.
And then eventually, like lots of us who work in enterprise were saying, yeah, but no one's going to change everything overnight. You're going to need to do, like, hybrid is going to be a thing. And then it turned out, it's like, yes, even AWS agreed with everyone and said, yes, hybrid is a thing. Like, who knew? It sounds like a very, very similar approach, but you're actually acknowledging that from the very beginning and giving people a pathway from where they are today to the future, rather than having to say, no, we're only for people who are doing things completely new.
That's right. And also compared to VMware, we are lucky that we were started in 2017 when it's clear a cloud is happening. And so in many ways, our technology were designed from the beginning with cloud in mind. So just from that cloud angle, we are actually embracing it fully from day one. And so from that aspect, we are quite different from the company who started 20 some years ago. But on the conceptually, I agree with you. We are taking the same approach of accommodating existing applications, as well as providing an SDK API to allow the new developers to develop new applications in different ways.
So what are some of the biggest challenges you see with potential customers, right? I mean, do you have to explain to them what PMEM is, or
Yeah.
are they typically well versed in technology?
Yeah. So our challenge number one is this initial introduction or education of our new category, which is big memory computing, including the underlying media with Optane, PMEM, or other persistent memory, and including our software-defined memory concept. And I think both of these are relatively new concepts to the enterprise customers, and that does take some explanation to do. So that I think is a primary challenge we have.
So where do you see the technology go, right? I mean, Optane is what we have today. What do you see moving forward, right? To continue the memory centric approach?
Yes. So one of the things we are doing right now is actually not have dependency on Optane. So we believe this big memory computing paradigm is not only Optane or not even only persistent memory. It is basically the concept where the memory capacity is bigger and cheaper and more function rich. And it can be enabled by whatever technology underneath it. And along with this vision, we are creating cloud instances where it will be just running on DRAM, but you can enjoy this memory DVR capability, enabled by our memory machine that allow you to roll back your application, branch your application in any ways possible, that you can try it out. And we will have eval version of our software that's also not dependent on Optane, where you can try out some of these functionalities. And So in some ways, it's like as an application user, I really don't care what type of actual memory hardware I use. All I care is a software-defined memory paradigm that allow me to do these high productivity, high availability things that was not possible before, and that allow me to become more efficient, more productive, and do more with less. And that's what we want to push out and make it really easy for people to try out, easy for people to consume, that hopefully overcome the challenge I mentioned earlier, the terms of introduction, explaining, and for them to have the servers ready for them to try out. This allows them to just get it done from anywhere, from even from their isolated home during pandemic. They can even try it out on their laptop.
Yeah, so listening to you, it seems like I don't need storage at all anymore in the future. It will be all memory be based.
We think in 10 years that just might be the case. But we also want to start this year. And again, in the spirit of not ripping things apart, I think storage has its space, have its place. Even 10 years from now, there'll still be storage, but they will be for capacity. They'll be there for archives, for backups, for whatever data you're not really accessing, but you need to throw them somewhere. So that will continue to be a strong need, and there's be ever-growing need. But for the live data, for the data that application need to access real time and the processing, all that data will not need storage anymore. And that's my belief. All that data will be in this new layer of big memory. And we believe this memory will be enabled by a pool of new heterogeneous, new media and new interconnect. And it's going to be enabled by new innovative software, such as our software.
I think that, to sum up the conversation, it seems like, one of the things that VMware discovered was, as Justin said, conventional applications need a bridge, a way forward in order to adapt to a new paradigm. And they also need mechanisms that enhance that new world of that they find themselves in. And they need a way to kind of step forward into the new world in some way. So from that, metaphor, we have sort of virtual machines, then we have, VM services, and then we have, VMware in the cloud. And I think that that's really what I'm hearing from MemVerge as well. And that, if we're going to be able to make use of this persistent memory technology and this new data center architecture, we're going to need to figure out a way to get conventional applications to run using this new capability, using this new technology. We need to find a way to enable new functions and features that enhance those applications. And then we need to give them a path to implement this stuff natively so that in the future, the role of storage in applications is dramatically different. So for me, that seems really to be the summary. And Justin, maybe I'll ask you next, what do you think the summary of this conversation is?
Yeah, I think that's definitely what I would see, is that we have a bridge here to a new form of technology, and people have forgotten what the technology felt like when it was new. Like VMware's been around for a very long time. Containers are probably something recent enough that people understand what it felt like. Cloud to a degree as well. Like it's just so different and so new that very few people fully understand how to take advantage of it. And the people who do embrace it with both hands, and they think that it's amazing and do all sorts of incredible things. But there's this long lag period between that happening and the rest of people figuring out how to use this and, well, what does this mean for me? Change is scary. And they need a way to figure that out. And one way of doing that is making it look a lot like what they already know. So you can use things, and like for MemVerge, the ability to use snapshots. So, well, I already know how to do snapshots. But the thing about what MemVerge does is the snapshots actually behave a little bit differently because it's persistent memory. So on one level, it's the same, but I get exposed to the new way of doing things. So I have the freedom to experiment and get used to it. And that opens up the affordances of what this new technology will do. And then we see people start to experiment with it, try new things. And really, that's where I see this going, is that I don't think we fully understand or can appreciate what this is going to look like in the future because we haven't invented it yet. And I'm quite interested to find out what people do with this when they get a hold of it and start pushing it in new and interesting directions.
How about you, Fred? You're our resident data analytics expert. What do you think of this?
Yeah, I do think it's a great addition. You know, persistent memory in HPC world. One of the big issues is that they want to take regular snapshots. I mean, you have so much work that's being done every hour. The last thing you want to do is to lose that data, right? So snapshotting today happens by writing to disk, which is, from a performance and a latency perspective, it's quite horrible. And it's also a cost perspective, because when that's happening, nothing really happens on the system. I also do think that PMEM has a great solution for applications that are today memory hungry. You know, I'm thinking databases and so on, where memory today is being achieved by buying and clustering multiple servers, which is also a licensing cost challenge. So from that perspective, I do believe that today the low-hanging fruit is the people that have a need for more memory. I do think also that Kubernetes and containers by themselves will push more demand for memory-centric, and certainly the memory capsule we talked about earlier. And finally, you know, regarding to Micron, I do think that they just made a business decision, and it's just more opportunities for Intel. It's just a stepping stone for me, from my perspective, to future technology.
Charles?
Yeah. So I have 3 points, I think, to summarize. And by the way, Stephen, I agree with your summary as well. I think the first one, my point is this concept of big memory computing, in my mind, is inevitable. It is imperative from the application and from the data that the world will be moving in that direction, where the live data will be supplied from the memory-centric tier. My second point is, to enable this, it requires an ecosystem of collaboration from many companies. On the hardware side, it certainly needs people to continue advance and invent on the media side, such as Intel Optane persistent memory, and there are others working on alternative memories. And what Intel told me is they actually welcome these alternatives to create this market together. And even with Micron's announcement, their focus will be on the CXL connected DRAM and other type of memories that also in support of the general direction of big memory computing. So we think it requires different companies to contribute different things from hardware front, and it requires companies to contribute on the software front, such as MemVerge, introducing this virtualization layer that helps the adoption of existing applications, as well as the development of new applications. My third point is that even though this is a 10-year trend that we are predicting, there are use cases that you can take advantage of it today, that we have introduced really 2 ways or 2 big values that we can provide. The first is more on the infrastructure front, where the consolidation of servers, where memory capacity is a bottleneck, they can use less servers to achieve the same objective with less cost. And that's really a strong value proposition for a certain class of customers. And the second is really to deliver a new memory-centric user experience that can increase the performance, productivity, and availability of your specific applications. And we are happy to start working with customers on both of these areas, and hopefully on our way towards that big memory future. So that's my summary, and it's a pleasure to be here.
Well, thank you very much, Charles, Justin, and Frederic. It's always great to speak with you. And this was a really interesting discussion because it really goes to the heart of the meaning of Gestalt IT, bringing together the various components of IT into a unified whole. And I think that's really what we're talking about here as well. If you enjoyed this discussion, please do subscribe. Go to youtube.com/gestaltit video, and you'll find more discussions just like this. You can also find more at gestaltit.com, as well as our podcast feed, our weekly news rundown, and of course, our Tech Field Day events. To learn more about the MemVerge solution, go to techfieldday.com and search for MemVerge, where you'll see a lot of deep dive information about this technology, including a demo of it in real time. You can also go to memverge.com and learn more about the solution. Thanks for joining us for this Gestalt IT Roundtable.